So our topic today is ignition testing, more specifically, modern ignition systems testing and analysis. So we might think, oh, well, why do we even test ignition systems anymore? Do we need to test ignition systems? Can we test ignition systems? And the answer is absolutely we can. And we really need to. Because we think about a few things. So has OBD2 eliminated the need to test ignition systems? The code tells us exactly what's wrong with the car, right? We know, I'll know that. Doesn't tell us exactly what's wrong with the car. And if one of those things that is required to drive a car, ignition, compression, fuel, air, if one of those is off, ignition being one of them, then I could have a drivability problem. And I could have a drivability problem that doesn't set a code. So, of course, we need to check. How about newer ignition systems designs? Coil on plug. The newer coils that we're seeing, we're going to talk about a little bit later as well. Has that made it so we don't test ignition systems anymore? No, absolutely not. You ever had a failed ignition coil and a coil on plug coil? Happens all the time. Twice on Thursday if it's a Ford, right? So had a lot of ignition failures out there, and oftentimes it can be a coil, and it's a lot easier than just swapping. It could be the coil, it could be fuel. We could see if there's a problem with the fuel system in there as well. And how do we verify ignition system performance when we're diagnosing a drivability complaint? And that is with ignition testing. So here's a little one. I know I've told this story before, but I think it's very wonderful to have a visual of what's going on under the hood, right? So this is what we call a raster pattern. So you can use this on a scope with ignition, full-on ignition scope capabilities like a Zeus Plus Verus series. They all have them in there. And what it does is it stacks all of the coils or all the cylinders on top of each other so I can see what's going on and compare them time-wise. How's my burn time? So we see these 6 cylinders. It's a 6-cylinder vehicle, and they were testing this. And just at idle, they all look fairly close. There's a couple of them are a little longer than others, a couple of them are a little shorter than others, but by and large, they're all fairly close. They're all fairly level, which we're going to talk about a little bit later too, looking at the firing line to see, or the spark line to see what else is going on in the cylinder. So they said, all right, so we don't really see anything going on here, and we know we have a miss. So let's put it under a little bit of a load. So they did the brake, match the brake, match the gas, do a little brake torque there, torqued up the engine real good, and this is the pattern that resulted. Now, as we'll talk later, this indicated on cylinder 5, because it just goes 1 through 5. Cylinder 5, where it goes out and then it comes up sharply at the end right there, that indicates a lean condition in the cylinder. All right, so we can see that for sure that is the spark voltage will go up the less fuel we have to burn. So that is an indication of a lean condition. So in this case, they ended up tracking it down. It wasn't anything to actually do with the ignition system, but testing the ignition system helped them to suss out that it was a bad fuel injector. Just clogged fuel injector, wasn't spraying enough fuel under a load, and that was causing it to run lean, and it was giving it a lean miss on that cylinder. So one of many examples of why we would want to test ignition systems. Even into 2024. Crazy, right? Now, when you think about an ignition system, we've separated into 2 different circuits. And I know this is an older style system, but it's going to be laid out pretty much the same. It's just going to have less components now, right? So we have our primary side and we have our secondary side. So the primary side is going to be anything leading up to and including the primary side of the ignition coil. So we have primary and secondary coil in there. And that includes the battery, any ignition switches, any ignition modules, igniters, any sort of pickup coils or cam sensors, crank sensors, those types of things are all considered part of the ignition primary because it's going to help the computer know when to fire that coil. And then anything on the secondary circuit is going to be anything from the secondary coil on out through the spark plug. Now, in this case, this is an older cap and rotor picture. So I would have a coil wire, and that would be included, and then the distributor cap, and then the rotor, and then the plug wire goes down to the plug. On a modern system, coil on plug, you would just have the secondary coil, and then probably a little spring in between to keep contact on the plug, and then out to the plug and the spark plug gap. Anything all the way out through the spark plug gap is considered the secondary coil. Now, I mentioned primary and secondary, and an ignition coil works on the principle of mutual induction. So that is a transfer of energy from one coil to another when they're placed in close proximity to each other. Now the coil that's connected to a voltage source, so remember how I said the battery was part of the primary side. That'll be your primary winding, the primary side. And then the second coil can be connected to another circuit, and that is going to be your secondary one. You will have, when it comes to an ignition coil, you will have different amounts of windings depending on what side of the coil it's on. So we have a common conductor in here, and that is going to be usually like an iron core in the middle, electromagnet. And you see on this side, we're going to have copper wire, and it's going to be 10 turns of wire on this side. And on this side, we have 1,000 turns of wire. So that gives us 100 to 1 difference. 10 times 100 gives us 1,000, right? So I have 14 volts and 14 amp supply, which is going to give 196 watts available energy for it. When that coil charges and then turn off to collapse the magnetic field, it's going to transfer that energy across. Now the wattage stays the same. My voltage goes up by a factor of 100. So 14 times 100 gives us 1400 volts. My current actually goes down by a factor of 100. So 14 divided by 100 gives me 14 hundredths of an amp. So that's how we can get 10, 20, 30, 40,000 volts out of a coil, and yet it's still, the current flow is very low. So we just need to be aware that the coil, that, you know, we're not dealing with 10,000 amps, we're dealing with 10 thousandths of an amp perhaps in that case. But that transfer of energy between the two coils is what gives us that large spark on the other side of the coil. Now, using that principle can help us when it comes to testing the circuit as well. So we can see here, this is a secondary circuit, and this is a primary circuit, testing on the same coil at the same time. And I'll show you how we would hook up here in a minute. But on the primary side, you see I get a firing line, I get a spark line, I get some coil oscillations there, but it's not very pronounced, right? I can't see a lot of detail in that. I can't see actually, oh, this is like 60,000 volts or 30,000 volts or whatever it is. Versus on the secondary side, depending on how the coil's set up, and we'll talk about that in a little bit too, gives us a lot more detail. We can see a lot more nuance into the signal. You can actually see that it's curving up considerably at the end, and I have quite a bit more oscillations there. So it basically just amplifies what we're seeing both sides, because once again, that step up voltage from the primary circuit to the secondaries. So when I want to get into ignition testing, what do I need? Well, I need a lab scope capable of ignition system testing first and foremost. So Veris, Zeus Plus on the Windows side of things when it comes to Snap-on, and then Modus and Triton tools on the non-Windows side, they still are capable of doing ignition system testing too. They're not, there are differences between the two different types of tools, and we'll talk through that in a second. But I need a scope capable of ignition system testing. Also, I get asked this quite a bit when it comes to ignition testing with our scopes, with the Snap-on scopes. You do not need an attenuator in line, just because of how our probes are set up. They don't. It's very small voltage being fed to the tool, because it's just it's a capacitive pickup, and it just kind of it's a low voltage. It's able to pick it up and convert it into a signal that translates into 10,000, 15,000 volts, whatever. All right, so you don't need to worry about attenuators. Get that question a lot. Some tools of the trade. We have an inductive sync probe, so that'll work with any of our 4-channel scopes. So Zeus and Veris, maybe old Modus, the old school, you know, the big Modus, the original Modus, because they have that extra D-sub connector on there, which is where that connects to. Now, what this does is we hook this onto either the first plug wire, if we're dealing with a car with plugs and wire, or plug wire, or you can put it around the power supply on the number 1 coil, and it should still be able to pick up a sync as well. This is just going to tell the tool number 1 is firing, so that way it knows when it knows what the firing order is, it knows where number 1 is, and then it can just kind of figure out what's going on. At a bare minimum, to do secondary ignition testing, you would need this adapter right here. So it's got a yellow and a black, and then it's got this RCA connector. If you know anything about like audio systems or like older school audio and video systems, they use this RCA connector, and that connector plugs into any of our probes. So in this case, you can buy a kit with actually all 3 of these. You can buy a kit with just the 2 of them. You can buy just that wire separate, depending on what you need. This is a capacitive probe that clips over the plug wire, if applicable. Some folks have also found that you can unscrew the top of this, and then it has a little nub on the end, and you can actually put that little nub on top of a coil pack, on a coil on plug, and oftentimes you'll be able to read the signal off of it that way too, just by sticking it on top of the plug. So extra added uses if you already have one of these sitting in the bottom drawer of your toolbox, which you may, because they used to come with like the first and second generation Moduses and the early Variuses came too. So you may very well have one of these hanging around, just collecting dust in a bag somewhere if you're not using it all. Some other ways we can do this, we have a stick pickup, and we also have these flag pickups. The flag pickups are available in singles, doubles, and triples, and they are daisy chainable. So it's you got a male and a female, so I can just string them together for however many cylinders I need. And that's for coil on plug, and this is the least expensive way to get into it too. So you can get a whole set of like 8 for like, I think, just over $100, or maybe even a little less. So that is by far the least expensive way to go about it. There's also various coil on plug specific adapters for different types of ignition systems. There's one for like HEI. There's one for the Honda coiling cap, the older ones there. And then there's various different adapters. Here's one I got right here sitting in front of me. It's a COP3, right? So that's got the RCA plug on it there as well. And they're made to fit individual coils or certain types of coils. There is another one that we have that's called the COP11. We actually just redesigned, and that's kind of universal. It's got a little slide on it, and you can tighten it down and put it on different types of coils. And I'll actually show you a pattern here in a little while that I just captured last week on a 2024 Hyundai. So yes, you still can test ignition systems. You might just need different tooling, that's all. And then you might have one of these sitting around somewhere too, because these have been around for a long time. This is a Sun Ignition Analyzer, which is what that SIA stands for. SIA 2000. So this was actually originally designed to work with waste spark vehicles around the late 80s, early 90s. GM was real big on that. Subaru used it up until the mid 2000s. Other manufacturers, a lot of other manufacturers use waste spark as well. So it's actually got a positive and a negative side. You clip them on both sides, and then you can actually get both sides of the waste spark system on the screen at the same time. Newer versions of these also are available with 8 RCA connectors. So it'll actually plug 2 on the negative side, and it'll give you RCA connectors. And that way you can hook up like coil on plug to the vehicle and then just have one main way of connecting it back to the screen. So if you have one of those, it's still viable, usable accessory as well. All right, so once I'm hooked up and connected, I would just connect to each individual coil if I have coil on plug, or individual plug wires, or on the coil wire itself on the vehicle, depending on what I needed to measure. So in the ignition scope, or actually in any of our scopes, you can look at least a single cylinder ignition on the screen. All right, so any of the tools with a scope, you can just hook up, go to an ignition setting, and you can see at least just a single cylinder on the screen. This one we kind of got like 1.5 cylinders. On the tools of the ignition scope, so the Varus and the Zeus, it's going to have a parade pattern that you can also use to measure voltage. So what you're going to use with these is you're going to compare, what does my firing voltage looks like? What does my spark line voltage look like? We're going to talk about what that means in a little bit, when it's higher or lower or what. But for example, in this one, seeing it in a parade pattern, I can have all my cylinders on the screen at the same time and see, is one higher than the other, is one lower than the other. And then that would be my suspect cylinder. The one I would want to look at is the one that's the odd man out. All the rest of these are fairly even. So I'd want to look at that one, and that one may or may not be a companion cylinder, because those are both kind of with each other there. So that may well be. It just kind of depends on how the vehicle's set up and what cylinder. But I can see that there's definitely something going on with that cylinder because of how much taller that firing line is. We saw the raster pattern a little bit earlier, so that's used to measure time. So my spark duration, my spark, how does my spark look? How does my spark line look? And then there's also a superimposed pattern that's in there. It's kind of a holdover from the older scopes because it doesn't actually label what cylinder is what. I can see if there's one that's the odd man out, but I can't tell which one it is. So you would have to go into one of the other patterns and kind of figure out what one it is. So it is useful for seeing whether or not the cylinders are running fairly evenly, but other than that, I wouldn't know what cylinder is the odd man is. That's just in the software. It's just doesn't have the can't determine between each. All right, so to do a primary voltage test, however, I don't even need any special tools. I just need a back probe, and then I would back probe on the coil primary circuit, so the voltage supply, and I can take a look at and see. Now, in this case, this is a the way this coil's set up. It's got kind of a built-in igniter, so it's a little more difficult to get patterns off of this. This is off my Subaru. But you can see there where the voltage comes in, it's about 14 volts, and then it drops off a little as the coil charges. And then when the coil fires, you do get a little spike there, so you can actually see that. And then it kind of levels off. There's really not a lot of spark line to see there. On some coils, you can get a perfect pattern that looks almost exactly the same as the secondary side. I know like the Nissan, the 2-wire coils, those are really easy to see, and they still put them on Sentras nowadays, by the way. I had a 2024 Sentra a couple months ago. It was like the cleanest primary pattern I'd seen in a long time. So it can still be had out there, it can still be accessed. So you see the voltage drop, and then you see a spike. And it should follow the secondary pattern here, so I just put a secondary probe on it as well. So there's dwell, there's where it starts charging the primary side of the coil, and that's where it collapses, and that's where the firing line is right there. And then the spark line here, and then that. See that? Primary versus secondary. Primary current, we would put that on the power supply as well for the coil, and then we would see what that looks like. Now, on the majority of vehicles, I will say, because there's going to be an oddball I'm going to show you in a little while. There's a couple oddballs. On the majority of vehicles, we want to see a nice smooth ramp up here. Now, in this case, it goes from 0, it goes up to about 12 amps, and then when it gets up there, it levels off. So this is what we call a current limited design inside that coil. So the manufacturer decided, I don't want more than 12 amps flowing into this coil. So once it hits 12 amps, we're just going to stop it, and we're just going to level it off until the coil fires. When the coil fires, of course, we're going to get a sharp drop off, because that all the current flow is going to be used to get that voltage to jump the gap. And if we were to compare current flow versus secondary voltage, we can see they line right up. So as soon as dwell starts, we see the coil start to rush in. And then as soon as the firing happens, the current goes away. See that? Now, what if I had a problem inside my coil? Here's an example of bad primary current. So instead of making a nice smooth curve, that goes up very sharply and then over. So that indicates some issue with the windings inside the coil, because it is needing a large amount of current to even get started. And then we see like a normal flow there. I clicked accidentally. Now, in this particular vehicle, it's a BMW, so it actually is multi-strike ignition. So you see multiple strikes in there. And I also want you to note that on this bad coil, the current flow goes up sharply and over, and then each subsequent event where it charges and fires goes up higher and higher and higher, because it's not able to dissipate. It needs to overcome all of that. Versus if we go on to a coil that was replaced after in the same scenario on the same vehicle, we see that it goes up in a nice ramp. In this case, it's not current limited. It just kind of goes up and then goes down when it fires. And then you will see the sharp rush on the rest of them, because it has to overcome the current that's already in there. But notice how I have kind of a downward trend. So bad was an upward trend, and sharply, and then downward on the good coil, downward or level. Put it that way. Another example of something we can do is check our ignition control, make sure that the computer is actually turning it on, turning it off. So you would back probe there on the ignition control circuit. So you got power, ground, and control. So in there, I should just see 5 volts. It's almost always it's a 5-volt square wave. And that should coincide with dwell. So when it sees 5 volts to the coil, that's the coil's indicator that it says, okay, I need to charge up my primary coil. And then when it releases that 5 volts, that's the indication of the coil that, hey, I need to fire now. So if you have a coil that has a separate coil control, that's where you're going to see. And notice how the secondary lines right up. Well, when that starts, goes over. When it goes away, it fires. Microseconds in between. And then we can also check secondary voltage. Now, on the majority of vehicles, there are some vehicles where it's darn near impossible to check, but the the majority of vehicles nowadays, you can still test it. You may need a coil on plug adapter, or there could be a couple other different ways to do it. But for secondary voltage, you're going to hook up to the spark plug or coil wire if equipped, or directly onto the coil on plug system. In this case, we have flags, and it's going to look something like this. So I have my dwell, I have my fire, I have my spark, and then I have my recover. So here is a textbook view of what that would look like, just a line drawing. So dwell is where that primary coil is starting to charge. You're going to see some oscillations here as the voltage builds into the coil. You're going to see some oscillations here. Then it should fairly level out. And then when it fires, I should see a firing line, a sharp spike. And then the spark line should come out, jump out horizontally. And then depending on what we have going on, it might go up, it might go down, it might stay fairly level. Those are three different situations as to what's going on in the cylinder. And then depending on how efficient that coil was at firing, you could see just a couple oscillations or multiple oscillations. This is basically just whatever's left over after firing the spark plug and after combustion, whatever's left over, you're going to see these oscillations here. And then it starts back over in dwell again. Okay, so every time it fires, it should look something like that. And they should be fairly even cylinders selling. If not, then you know where you need to look. So when it comes to the firing line, the voltage of the firing line is going to be dependent on conditions inside the cylinder. So high firing line voltages can be caused by wide spark plug gaps because it has a wider gap to cross, so it needs more voltage to cross that gap. Lean air fuel mixtures, because lean gives me less hydrocarbons to burn, so it's going to have more voltage that's necessary. High cylinder pressures, because the higher the pressure, the harder it is to split those molecules apart. And retarded ignition timing, because of where it is in the stroke of the piston, will require higher firing line voltage. So you're going to check the firing line either as a single cylinder or with other cylinders for comparison. I would definitely do that because you don't want to just pick the one that you think is bad and then why is it bad? Because it's bad. So you always want to check at least to one other thing for comparison. And that's true for pretty much any component on a car, as if you have multiples of them. Typical tests that we can do, though, is cranking test, cruise tests at about 2,500 RPM, just hold the throttle, and then a wide open snap. So here's an example on my vehicle cranking test. You'll see we got about 10,000 volts, roughly 10,000 volts on the firing lines. You can see that you've got spark lines there too. So that is on, I have all four cylinders. I have a flag on each of the four cylinders hooked up to the tool, and that's just cranking. Wide open throttle in this case too, because I don't want it to fire. So I just hold the pedal down, crank, crank, crank. Here's an example of a bad pattern. I would not want to see this. Or this would indicate a problem with the vehicle, let's put it down. So I captured these while I was in the middle of doing a tune-up to the car. And I had about 120, 130,000 miles on the plug. Don't quite remember how many it was when I changed them, but like, oh, I need to change the plugs. Perfect time to do this because I can see the difference between fresh plugs and old plugs. Fresh plugs and old plugs. So this is a cranking test after I had replaced 3 of the 4 cylinders. Notice how this one is considerably higher. It goes up off the screen. 18, 20,000 volts, something like that. That's the worn out spark plug that had a much wider spark plug gap than the other ones that I just replaced. So due to the fact that it had a much higher gap, it needed more voltage to go across that gap and actually fire. So that is definitely telling in that. Here's another example on a different vehicle that had a bad coil. So you can see it's barely pushing anything out, and I do not have spark lines. So the coil was just not creating enough to cross the gap. It was kind of firing, but it wasn't really doing it. So that's an example of what a bad coil might look like. Now, when I do a cruise test, so that's taking it from idle and just holding it at 2,500 RPM, we can see that the firing lines go way down because of the timing advances. Remember how we said retarded timing requires higher? So the timing advances, so it goes down. At that cruise test is unloaded as well. So we can see that we do have a lot more turbulence in the spark line as well, which we'll talk about. And then wide open throttle snap test. So we should see that go up It should increase off of idle, and then you'll see a uniform decrease after the throttle closes. So they should all kind of go up in unison as it goes up towards, whatever your top RPM was, and then they should come down uniformly and recover. We should also see the higher the RPM is, we should see a lot more stuff going on in the spark line too, because we got a lot more swirl going on in the combustion chamber. That's what it's actually representing, is the swirl in the combustion chamber. So the link and shape of the spark line will be affected by conditions inside the combustion chamber as well, just like our firing. The spark line should jump out horizontally from the firing line and show some turbulence. Like I said, we should see some ups and downs in there. The spark line can be anywhere from 0.85 milliseconds to about 2.5 milliseconds in length. Lean mixtures increase, rich mixtures decrease, like we said. So how do we show that? This is on a different vehicle. So this is on a vehicle with a spark plug wire ignition, so conventional ignition. So we see the firing line there. We see the spark line there. We see that spark line is fairly flat. And I do have a little bit of turbulence in there. Not a lot going on. This is at an idle. So fairly even. So I decided to lean out the cylinder. So I started pinching off the fuel line coming off the fuel filter under the bay. And you can see where it's flat. And then all of a sudden it goes up at the end. And then it almost stalled, actually. So you can kind of see a little bit of that going on there. But it's flat because it has enough fuel. But once it starts running out of fuel to burn, we'll see that nose up at the end go up. All right, so that's an example of a lean condition, how it kind of goes up at the end. Here's an example of a rich condition. So this was on my car. I was doing a tune-up too. Before I did the tune-up, I wanted to see what it kind of looked like. Now you see how it kind of dips down and then levels off. So rich means I have lower voltage that are necessary, and then it kind of leveled off over here when the mixture kind of leveled out. This one is actually straight. It kind of looks like it's going downwards because that's just kind of probe placement and how the probe works on this particular coil, because it's got not a traditional design. It has the igniter inside of it and everything, so it's more of a modern coil. So you're not always able to get like perfectly flat lines with what you're looking for, but you just want to see, is it straight? Yeah, it's going down, but if I compare it to this one, I have that lump right there, right? So that's an indicator of a rich. That's an indicator of it's flat. I'd call that flat. Very little oscillation at the end too. Very efficient coil. Here's another example of this is just at idle. It was on like a Ford Escape or something, I think. It had multi-strike ignition on this Ford. So we can see how it just kind of fires multiple times in succession there. We can just kind of see how it just kind of goes. And you will see multiple firing lines on multiple strikes. Now, this is a modern ignition system class, so we're going to talk about modern coils in the last so odd years. So Hemi engines on your Chrysler, Dodge, Jeep, Ram vehicles, your 5.7s and your 6.4s and things like that. Anything with the Hemi engine or the higher end engines, the bigger V8s, are going to have these weird looking coils. And these cannot be tested using secondary testing methods because of how they are internally wired. Now you see there's also 2 spark plugs that come off it. So that'd be interesting trying to even capture a pattern if I could. So you see you got 2 spark plug holes in each cylinder. And then pretty massive valves there, but you'd have 2 spark plugs in a cylinder. If you look up the information from Chrysler, you'll see the 3.6 does not have that type of coil, so you can see that. But the 5.7, the 6.2, and the 6.4 all have the same spec because they all have that weird double coil. And it says over here, the secondary resistance is this, but you can't measure it directly due to the diode in the circuit. So you wouldn't even be able to test it and measure it directly. But it's in there. I suppose if you disassembled the coil, you might be able to figure that out. But the primary side, we can see what we want to see. So that's just information directly from the manufacturer, not directly measurable. And then there's this 2024 Hyundai Palisade. Now, I'm pretty sure it goes back a ways. I think I saw a replacement coil for it goes 2017 to 2024. But I get this question a lot too. Not necessarily on Hyundais, more on Hondas. Because they have a very similar design inside their coil. So you still have primary coil, you still have secondary coil, right? There's primary, there's secondary. Still goes out to the spark plug, still have current or voltage goes in. And then I have a ground, but I also have an ignition signal and I have a igniter in there and I have a diode in there. So it makes it very difficult because of that built-in igniter to actually get patterns that are usable. Now I was able to get some interesting patterns off this. First one was a current ramp, so I put a current probe around the positive side, and that's what I got. Not really a lot of rhyme or reason when it comes to what's going on as far as the firing line or anything like that. It's just a whole lot of oscillations back and forth. But that's just, that was real life what we saw, right? So it just looked like that. Now, when it came to secondary ignition, I had that COP11 adapter that I talked about earlier. It's kind of adjustable, put it on the top. That is a different type of adapter. I forget what type they called it, but that it is able to give you a pattern on some of these newer design of coils. It's not going to tell you, oh yeah, here's what your voltage is, but I can at least take a look and see if the pattern is fairly close to what a good pattern is. You can definitely see good detail on dwell when it charges. There's dwell there. And then the firing line, oh, it goes negative to positive. So that's unusual. But that is just how the pattern presented itself on this vehicle. So I do have a firing line. I do have a lot of oscillations here. I do have a spark line as well. It's fairly level. And I do have some coil oscillations there. So it was able to get me a pretty darn good pattern, at least to analyze what's going on. It says it's meant to measure burn time is really what it's meant to do. But I definitely could see if it was going lean or rich or whatever. I think I would be able to get enough detail out of that pattern. It was just something kind of interesting. I hooked up to it for the first time, sight unseen, not knowing what to expect, and didn't get what I expected. And that happens sometimes, hooking up to cars that you don't really know how they're going to look. And then you look at it and say, oh, okay, that makes sense, how the pattern is. But yeah, it's kind of interesting information. So that's how you would see it using that COP11 adapter. Interesting. All right, let's do a quick little walkthrough live on a couple of the scope functions on the vehicle. Now, if I was just going to guided component tests, you can do that. And I'm just going to pick my Subaru, I guess. Non-turbo. And if you go into engine and you can go into ignition. Now, this has, once again, the coil test that we can do, and we could do a current ramp test on it, but it says we can't do a secondary test on this, and that is due to the design of the coil. So a current ramp test is going to tell you how to hook up. There's also that COP11 that I talked about is available to do to check burn time readings, etc. It's just going to kind of show you how to hook up and do your different tests on that vehicle. So pull up your vehicle of choice inside guided component test. It's going to walk you through how to do a few of those. Otherwise, if I have a 4-channel scope like a Verus or a Zeus, I can go in here under scope multimeter. And this actually we have regular lap scope, which any of our tools, you'd be able to go in and do ignition on that. Or I can go to the ignition scope on my 4-channel tool. And you'll see I have options for parade, cylinder, raster, and superimposed. So we go into single cylinder ignition. That is what all of the tools are able to do. And you'll see I have a simulator hooked up here, giving me a simulated ignition pattern. So you see where kind of dwell would be, and then the firing line, and then the spark line, and then I got a couple coil oscillations there as well. So it's important to make sure you have the correct probe there. So ignition probe. Make sure it's inverted using the ignition probe, because otherwise it'll give you a negative ignition pattern, which it is by design. And then you can mess around with the scale a little bit to make sure it sets where it needs to be. The important part is going to be this trigger. This trigger, if I pull it outside of that pattern, it's either going to walk by or it's not going to show up on the screen at all. So I want to make sure that start around like 4,000, 5,000 volts. And that'll get you kind of in the neighborhood. It's a good place to start. And then just kind of see what the pattern is. Also, we have all these other patterns that are exclusive to the ignition scope part of the tool. So if I go on under parade, There's my parade pattern with all 8 cylinders in this case. Now, it's probably not going to look like that when you first go in there because it defaults to a different setup. So in order to change this, I can go under setup on the top, and I can go to setup again here, and then I can go to ignition. So setup ignition. I can tell it what kind of ignition system it has, how many cylinders it has, up to 12. Oops, hit the wrong button. If you hit the exit button, it closes everything. And then I can choose my firing order, right? It's going to give me all my combinations of firing order. The most common 1-8-4-3-6-5-7-2 is going to be on top. And then I can tell it whether or not I'm triggering off the coil or off the plug. So it says connect number 1 trigger lead to cylinder number 1. So I can put that on the primary side of the coil on plug or on the plug wire if it has a plug wire. Once I've done all that, told it how many cylinders, told it the firing order, it will calculate the RPM for me. And then there's also an option to show it on the screen, which I'll show you in a second. But it'll calculate the RPM for me, and it'll have the firing order. And when I do that, it'll put the firing order across the bottom. So 1-8-4-3-6-5-7-2. Now, this is a simulator pushing out the exact same pattern every single time it fires. So it should be no variance in this at all. And see, it does still vary a little bit just because of the signal generator. But what I want to look for here is these firing lines. Is one way higher, is one way lower. You can kind of see the spark lines as well. You can kind of see what's going on. This one looks like it's a little lean at the end. And then you got your coil oscillations there. So that's the example of a pretty good pattern. If I come down here on the bottom, I can change to cylinder. Now, as opposed to single cylinder, which I can look at one cylinder on the screen and kind of move it around. This one is a single cylinder. And then you'll see my trigger point here is this arrow. Now, if you ever have trouble getting an ignition pattern on in any of these views, use this triangle. Bring it down inside the pattern, it'll show up. If it's ever outside the pattern, it'll go away, and you won't see it at all. So that's your actual trigger point right there. So if you put it somewhere inside the pattern, usually the firing line is a good place to put it. That'll lock it on the screen. If I come down here, I can choose what cylinder is what. So since the tool knows what the firing order is, it'll go through the different cylinders, and I can analyze each one individually on the screen at a time. So that's helpful. Once again, just a generalized simulator, so it's not really going to change. And then if I go to raster, that's where it stacks them on top of each other. So I can go in there and I can see individual cylinders, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8 in this case. Doesn't label them, but that's how it's set up. And I'd be able to see if one of them was out from the other. And then lastly, of course, we have the superimpose. Like I said, that's going to be, I can see how evenly the cylinders are. Not much else I'm going to be able to do. There is one more little hidden gem before I go in here. If I go into setup and I go to view, actually there's a couple different things I can show you, and go to display. Show RPM is 1. So like I said, it automatically calculates the RPM. Show grid. It's going to put my grid lines on. You can use that for a lot of things. And then this one here, show digital KV. So if I ever wanted to do a printout of how this engine was running, what's the firing line? So what's the maximum, minimum, actual, the firing line, the tall thing. Spark KV is going to be where does that spark line jump out from the firing line when it comes back down. It should be around 2,000 or so, 2,000 to 3,000. And then burn time. What's my burn time? So I can see what the actual burn time is and what the min and max are on that cylinder as well. So if I wanted statistics on it, if I was like an engine builder and wanted to make sure all my cylinders are running fairly evenly, I could use this. I could print this out for a customer if necessary to see, what's the burn time, what's the spark line, etc. So all sorts of helpful things in here to help you analyze your ignition system. Now, this is by no means a master class on ignition, but hopefully at least it gives you enough to go on and enough to kind of get your feet wet. And the more vehicles you hook up to, the more different systems you analyze, the more you'll be able to kind of understand what's going on in there. So always good to hook up to known good running vehicles as well, especially if it's a coil design you haven't really seen before. Like I did last week, like I said, on that Palisade. That was a little different. So hopefully you picked up some tips and tricks on that ignition system and maybe even utilize it in the shop tomorrow on that weird drivability car, right? So that is ignition. So let's talk about what we're going to talk about next week. Next week, we are going back to our OEM specific training series. So if you know how we do it around here, we do about 6 weeks of training that are new. And then we do 6 weeks again, which gives you multiple times to catch the class live, ask questions, etc. So we are on CDJR next week. So 6 and 9 Eastern, as usual. Snapon.com/OT to register on Zoom. Otherwise, you can watch the 6 p.m. class on Zoom or YouTube. Sorry, Zoom and YouTube. Watch it on YouTube. Otherwise, the 9 p.m. Eastern class goes live to my Facebook as well. So that's facebook.com/SnaponJason, all one word, no dash in the Snap-on. I will say next week's is going to be pre-recorded for sure because I will be in Florida for our big tool show. So our Snap-on franchisee conference is next week. So it'll definitely be pre-recorded, but you can sure ask questions and I'll get back to them as I can. Should be a good time for all the franchisees and everyone going down there. Definitely talk to your franchisee if you're looking for any good deals. That is the best deals of the year when we go down there. And they're going to have some cool stuff to talk about diagnostic wise when they come back. So definitely want to talk to your franchisee about that. All right, if you want to see any of our other episodes in this series, anywhere from intro to ADOS all the way through our Mercedes-Benz class we did last week, this is actually class number 95. 5 more classes away from 100 classes. Crazy to think about. But they're all available on our YouTube channel for free whenever you want. YouTube.com/Snap-on Diagnostics. Scan that QR code if you want to subscribe automatically. It'll bring you there. It'll allow you to subscribe automatically. Very helpful. And they're all half hour, 40 minutes long. All useful information, I think. All right. And then do we have your email address? Maybe we do. Maybe you don't. I would guess we probably don't, knowing how many customers we have versus how many emails we have. So unless you gave us your email at the time you had your tool activated, we probably don't have it, and you are missing out on some other diagnostics related content. So technical focus articles, blogs, quick tips, new product releases. They also send out my schedule periodically so you know what classes we have coming up. You scan that QR code, it'll bring you to a form. You can fill out your information, put in your email address. Then we will have it, and then you will start getting information like, for example, how to diagnose a stretch timing chain on people. Many different ways of going about it. I know it's a very difficult thing to diagnose sometimes, but try to help you out with tips and tricks. So definitely worth it. If we don't have your email, scan that QR code, then we'll have your email. Time for questions. If we don't have, if you joined late on Zoom and you want to ask a question, just find that Q&A button top or bottom of the screen. Type in your question. I'll get to those in a second. On YouTube, feel free to use the chat. I want to also mention my buddy Keith, who also does free diagnostics training. His is product-specific training. So on Wednesdays, it's on Zeus Plus. Thursday, it is on Apollo and Training Tools. And these are about an hour and a half, hour and 40 minutes long. First hour is going to be setup functions. Let's set up your Wi-Fi. Let's talk about Snap-on Cloud. Let's talk about Snap-on security link and things like that. And then on Thursday, it is all about, yes, that's the first hour. Never mind. I got confused there for a second. And then he takes about a 5-minute break. And then the second hour is going to be the scope and meter functions on the respective tools. So tips and tricks on that, how to hook up, how to use guided component tests, etc. So well worth your time, I think, about an hour and a half, hour and 40 minutes. Zoom only. Go to snapon.com/OT to check that out. Now let's get to questions. Looks like we are clear on Zoom. Light evening today. Check on YouTube. The Winton, hello. Thanks for checking in as always. You're here every week live. I appreciate that. Same thing with Nick from the UK. It is very late for you, but absolutely great for you to be joining us as always from the UK. I appreciate it. Nick also can't wait for the next training class. Thank you very much for the free training, he says. And enjoy your weekend, he says as well. Jaylee Lobo says, great class as always. Thanks for your time. Thank you, Mr. Lobo, for always participating in class. Nick also has a question. So why are techs leaving the automotive industry? Hard to say. I think there's a lot of factors as to why techs are leaving the automotive industry. I know it is overall, at least in the States, I don't know how it is in the UK, but in the States, I know it is an aging workforce. So they're retiring out, and we don't have a lot of young bucks coming in to take over. And a lot of that has to do with like my parents' generation telling my generation, oh, you got to go to college, you got to get a 4-year degree, you got to become a doctor or a lawyer. They didn't really talk about the trades too much. Now it seems like we're kind of reversing because they've realized that, oh, we don't have a lot of techs coming into the industry anymore, and we do need techs. And you know what? The other thing about being a tech is you need constant training to keep up with all the technology on these cars nowadays. It's going so fast nowadays and progressing and changing like every week. So we definitely need to keep up with it. I know I need to keep up with it because I'm the one who has to teach people about the new technologies that are coming out as well. So it is just a constant be learning. And then plus the other factor I might say, I know one of the reasons I got out was not enough pay for the amount of abuse you put your body through. So that's just my 2 cents there. Didn't mean to go off on a little bit of a rant there. Let's see. John Broem says 4 channels better for testing coils than the 2 channel when testing. So the difference between the 2 channel and the 4 channel is going to be those ignition scope specific capabilities that you'll get with the 4 channel tool. You can still test coils individually. You can test 2 channels worth of coils on a 2 channel tool, of course. The 4 channel tools, like I said, though, will have those specific ignition scope, like the parade, the raster, and the cylinder by cylinder testing that's available on. So just a matter of how much you're going to be doing it. And Jay says, enjoyed the class. Thank you very much, Jay. Glad you enjoyed it. I enjoyed having you here. Let's see. Looks like we got a few more questions. Richard Brooks says, hi, have a good evening. Enjoy the class. Keep up the good work. Thank you very much. Nick also says, according to his statistics anyways, I haven't seen any, it might be UK only too, but only 3% female techs in the automotive industry. That's not really good for the industry. I would agree. You know, it's good to have anybody in the industry at this point, really. Let's see. Anthony is inquiring about forming a scan tool PID list from 2 network modules at the same time on Snap-on scan tools. Yes, that has come up in discussion actually fairly recently because like the heavy duty tool can do that. And I was wondering why we couldn't do that on ours. So that came up in questions. So we're looking into that one, Anthony. So thank you for that. I will make sure to bring that up to say, hey, other people are asking as well. And John has his 2 cents on why techs are leaving. And he said, flat rates making techs quit too. Could very well be a factor. You know, we're not getting 100 hours to replace frames on Tacomas anymore. And that was only people in Toyota anyways. But yeah, flat rate times going down, not paying the flat rate times, you know, that can kick your butt some days too. Especially with diagnostics nowadays. Oh man, I was the diagnostic guy and I was flat rate, but you know, they help me out in other ways. Sometimes they straight time me on some diagnostics, but yeah, being a flat rate diagnostic tech is not easy at all to make money for sure. All right, with that, looks like we have cleared both boards. So also with that, it's been a long class, which is nothing wrong with that, but as long as it's good information, right? With that, thank you very much for taking a little bit of time out of your day, spending a little bit of time with me. Hopefully you learned a few tips and tricks on ignition system testing. And maybe you can use it in the shop coming up down the road pretty quick here. So with that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.